Hello class. Today's lesson we're going to be learning about the focus of a parabola. So this is a new property. We're going to be learning about what's called the focus as well as the directrix properties of a parabola. Previously we learned about properties such as the symmetry of a parabola, but this is a kind of a new thing that we're going to be talking about today. We're going to write equations of parabolas based on focus information or directrix information. We're also going to be graphing parabolas in what I call a new form. It's actually a form, this is a word I'm going to use, focus form. So let's begin. And we're going to start off by defining a new way of defining a parabola. This is an alternative way. It's the set of all points on a plane equidistant from a single point, and this point we're going to call the focus, and a line which we're going to call a directrix. So this is what I mean by that. I have a line here, that's my directrix. I have a focus, this point up here. Now it could be in any direction. I could have made them, I could have made the directrix go in kind of an angle like this and the focus to be over here. That's completely arbitrary. But now I'm going to create a set of points that are equidistant from both the focus and the directrix. So this is the midpoint, or the point right in between. If I draw a straight line down perpendicular, this would be the midpoint between the focus and the directrix. You notice here it's perpendicular, so we always talk about distance from a point to a line being that perpendicular line. Here's another point, equidistant from both the focus as well as the directrix, and because of symmetry we have one on the other side as well. We have another point here, another point there. We connect them all together. If we were to draw all these points, we would have this graph here, which we call our parabola. Now, there's a very cool and interesting property about this focus. There's a reason why it's even called the focus, and this is the reason why. If I had a light beam that came directly down, perpendicular to the directrix, it would bounce off of this parabola and hit the focus point. So I could have, say, another ray that came straight down. It would then bounce off the parabola and hit the focus. And this works in both ways. This works for a satellite dish when it's receiving the radio wave signals from the sky. It bounces down into the dish and it hits this focus point. And this is how solar collectors work. This is how satellite dishes work. Flashlights work in the opposite direction, where we have a light here which is shooting out light. The light shoots out and then kind of gets reflected out, and so all the light beams then shoot out in this straight direction. So your flashlight will also have a parabolic shape here where the light bulb is right at the focus point. So that's the kind of cool property about this whole concept about the focus, and that's thus the reason for the name. We have the axis of symmetry again, just like we learned the other day. The vertex will always be exactly halfway between the focus and the directrix based upon this definition. Okay, so here's an example. And your notes, you need to fix it. This is the word focus here, not vertex. Find the equation of a parabola with a focus 0, 4 and a directrix y is equal to -4. So we're going to start off by sketching the picture. We don't have to, draw all the coordinates. A sketch is just fine. Then we're going to create a point. And I'm going to call this point x, y. I'm making up two variables for this point that I've created on this parabola. And I'm labeling the distance here d1, the distance here d2, and by the definition of our parabola, they are the same. Now let's figure out each of these distances. d2 is an easy one, so let's start with that one over here. Let's calculate the distance here. We could see that the coordinate point of this point down here, it'll have the same x coordinate, but the y coordinate will be -4 because of this line down here. So the distance is just subtracting the y coordinates, y minus -4. On the other side, for D1, we're going to use the distance formula, where we say, x minus 0 squared plus y minus 4 squared, and we take the square root of that. So now we set up our equation, and we're going to simplify this equation to get our parabola equation. So I square both sides at this point. Now I'm going to expand out the term here, the y minus 4 squared term. I expand out. I expand this term out as well. I can cancel out some terms, and I'm left with this x squared is equal to 16y. And I'm going to then solve for y, and I get this equation, which is our kind of standard looking parabola equation that we've seen in the past. And that makes sense because this is an upward facing parabola, and it's kind of on the wide side as well, or I just drew it that way anyways. That leads us to what I call focus form. This is now the fourth form. We've learned vertex form, standard form, intercept form. This is our fourth form, which is focus form. And by its name, what it tells us is the focus information. And in this context, in this equation, we're going to be using p as the kind of coefficient or variable, or not variable, coefficient. And this coefficient p stands for the distance from the vertex to the focus. And this is an important definition to understand. So we have different cases here. We have this up and down parabola case here, where the equation form is y is equal to 1 over 4p x squared. The focus will be, always on the kind of inside of the parabola. The directrix will always be a line on the opposite side, you could say, of the parabola. And again, the directrix is a line equation, so we specify it as a line equation with a y is equal to negative p. So when p is positive, it's going up. When p is negative, the parabola goes down. Now this is a new thing. We're going to actually be looking at sideways parabolas as well. We could look at this other form where we just swap the x's and the y's. And we have a symmetry here, and that makes a lot of sense. So when we put the x is equal to instead of y is equal to, instead of going up and down, it's going left and right. So when we have a positive value of p, the distance from the vertex to the focus, when it's positive, we have a right-facing parabola. When p is negative, it's left-facing. But everything else about it is just completely symmetrical to the up and down parabola type. Note also that the left and right parabolas, they're not functions. They fail the vertical line test, but we're still going to use them. They're valid equations. So now let's graph a parabola. Let's find the focus, let's find the directrix. So to do this, first step is to rewrite it in focus form, solving for the term that has kind of x to the first power or y to the first power. So in this case, x to the first power, we solve for that. Now, the second step is we want to find the value of p. We want to find the distance from the focus to the vertex. And so we recall our focus form, and we see this piece right under here where the denominator here, 1 over this number here, that's 4p. So I'm going to set up an equation where I say 4p is equal to negative 4, and I solve for p. In this case, p is equal to negative 1. So now I'm going to sketch this. I'm going to plot it out. So I have, in this focus form, the vertex is at 0, 0, so I draw that in. P is negative 1, so that means I go over to the left, I plot out my focus point, and on the opposite side of that I have my line, and in this case the equation is x is equal to 1. Always use a line equation here. Next I'm going to plot some points to graph out my parabola, and in the case of a left-right type of parabola, you see here the equation here? It's going to be more convenient to plug in values of y and calculate x than the other way around. Normally we plug in values of x to get y, but we're going to do it the opposite way here. So I'm going to plug in 0, I'm going to plug in plus or minus 1, plus and minus 2. I get the values here, plot them out, and I get my left-facing parabola. Okay, now we're going to write an equation instead. So given some information, we have the vertex at 0, 0. We have the directrix at y is equal to 6. First thing we're going to do is sketch, and it could be a very simple looking sketch, but this is what we draw. We draw the directrix first. Actually, let me back this out. We draw the directrix first and the focus, or sorry, we draw the vertex and the directrix because that's what we're given. Based on this, we know that the parabola shape is going to be going up or kind of downward like this, so we can then draw the parabola based on this information. Based on the parabola shape, we can figure out which form to use. Is it, y is equal to or x is equal to? Because it's up and down, we're going to say y is equal to, and this should be, hopefully whenever you see x squared, you think up and down parabola. So this is our focus form. And now we need to find the value of p. Well, the value of p, in this sketch up at top, we did not find the focus point. The focus point will be inside the parabola somewheres. Now in this case, the focus point will be at 0, negative 6. Since the directrix is going up by 6, the focus is going down by 6. So in this case, we find that our focus, or p, the p value, is negative 6. We then plug that into the formula, or the focus form equation, and we get y is equal to 1 over negative 24 x squared. And you could put this negative sign up here on top, or right here next to the kind of the fraction sign. I just chose to put it here just to kind of connect it with this right up here, but it doesn't really matter. Okay, here's another example. Find the equation of a parabola with vertex 0, 0 and focus at 1/4, 0. Again, sketch it out first. And let's, again, I'm going to erase the parabola here. We're going to draw out the focus, the vertex and the focus. And now we know that the parabola is going to be shaped kind of like that, where it curves to the right. And when we choose our form, we're going to choose the x form. X is equal to form. Find the value of p. In this case, p is 1/4. The distance from the vertex to the focus point is 1/4. So p is 1/4. We plug this into our equation here, our focus form, and we get x is equal to y squared. That's our answer. Now we can also translate the parabola, this equation, in focus form. So let's start with this initial. And using all the things that we've been doing in terms of transformations, if we want to translate the vertex to a new point, h, k, we do our translation in the x direction, translation in the y direction, and this should look actually very kind of familiar to you. This is actually vertex form. It just has a different value here. In this form, instead of using a, we use 1 over 4p because that kind of shows the focus information. We also, by symmetry, have this other case here for the x is equal to case, the right and left parabola case. Notice that the h and the k's are different. The k is always going to be associated with y because that's vertical. The h is the horizontal movement, and that's always going to be associated with the x. So let's use this. Let's create the equation of a parabola with this vertex and focus. And again, the first thing we do is we make a little sketch. So again, we draw out the information with the vertex and the focus point. And with this information alone, then we can then sketch out the parabola. It's a right or a left type. So this is going to then be in kind of an x equals type of form. So x is equal to this. we're going to figure out our values of h and k and p. In this case, h and k are given to us, and we could figure out the distance p here as well. So h and k is, again, just given. The p, again, p is the distance from vertex to focus. In this case, it's going to the left, so we consider that negative when we go from the right to the left. So p is -1. We plug all this in, and then we get this equation right here. Now let me fix this. I need a negative sign. -1/4 y plus 3 squared plus 4. Okay? Now let's end with a word problem. Suppose I have this satellite dish, a parabolic dish. The focus is up here, 6 feet away from the bottom. I have this dish here that is 10 feet wide. I want to figure out how tall my satellite dish is. So, first thing to do is find the equation of the dish. What is the equation that models this parabolic curve down on the bottom? So it's going up and down. So that's going to be a y is equal to type of form. I need to find the value of p now. Now, in this case, p is the value, the distance from vertex to the focus. That's given to us as 6 feet. So I plug 6 into the value of p here, and I get my line equation, or sorry, my parabola equation. Now I need to use that equation to find d. To do that, I need to figure out what to plug into x. X is really this distance from this point, the vertex, to the edge here. This is my distance of my x value, because I want to find this point up here. So the distance from here to here is 5. So that's the value that I plug into my x. And then when I solve it, I get 25 over 24, feet. Okay? So that's the lesson for today. Have a good day, class.